Thank you for joining the March 17th, 2020 VOLTA call. Just a reminder to everyone that these meetings are public and recorded, and we post them to YouTube after the meeting concludes. So starting off today, let's go ahead and take a look at our agenda. So first we have a logging demo. Let me see if we've got Divya on. I think I saw Girish. Whoops. No, let's see.
Yeah. Um, yeah, Julie, this is Girish.
Ah,
I'm on. Diva is also, I guess, on.
oh,
So,
great. Okay.
yeah, you can
Yeah,
provide
hi
me
Julie.
the presentation, right?
Okay. So let me go ahead and I'll finish going through the agenda really quickly and then hand it over to you to share your screen. Okay,
Yeah, sure.
thanks. So we have a couple other discussion topics afterwards, and then with any remaining time, we'll go over new JIRAs that have come in. And with that, let me go ahead and stop sharing my screen. And then you should be able to gain control now. And just a reminder to everyone, again, these are public and recorded, so keep that in mind during discussions and presentations. All right, we can see your screen.
Okay, great. Let me put it into a slide mode. Okay. Uh, all right. Hello, everyone. This is Girish. Me, along with my colleague Divya, are going to actually talk about the dynamic log level configuration features for Volta pods, which has been not probably I would say added recently, but yeah, it was thought earlier, but I think it has been slightly redesigned and to make it work through etcd. So as you guys know, there was some work done around the dynamic logging through the API earlier, and there were some shortcomings found there, and we actually then looked at doing it in a different way and implemented that. So I'm just going to talk about this what we had done through a set of 4 or 5 slides, and then Divya would continue and demonstrate what has been done. Okay, so when we started off, we actually consulted Scott and David and came up with a set of objectives for this feature. I hope you can see my screen, right? Transitioning to the next slide.
Yes.
Okay, all right. So we looked at objectives, which are basically we wanted to allow the log verbosity of the component to change in runtime. And we wanted it to persist across the pod restarts, and that was a limitation which was found when we did it through the API earlier, right? If the RW core used to restart, and then the log level configuration used to also go away. Then we wanted to support package level granularity, which is standard one, and then we wanted the ability to set the log level for multiple components together. Uh, the running pods should start reflecting within a reasonable time, so it should not be long of delay once you change the log level configuration. And then we wanted basically to utilize the same model which was already there through the VoltCTL to change the log level, but it should also be possible to change the log levels to the alternate API so that they can be a direct OSS integration. Please stop me if you have any questions and then and there so that I can probably answer them. I'll probably move to the next slide. So this was the objectives and the solution. The way we went about it was storing the log level configuration in etcd. And etcd actually today have the service / Volta as the base path, right, under which all the information is stored by Volta. So we introduced a new path under it called config, and under that the configuration related to it, different components are stored. The way it is done for log level is in this structure. So under config, there would be another path, subpath with the name of component. Under that, there's a log level, and under that, for each of the log levels which are configured, they would be stored under here. There would be one default, and then there would be package level logs. Examples are shown here. So you can have a component name as Volta RW core, and then the package name of Kafka. And level is one of those 5 levels in a string format. Same way you can for component 2 log levels would be stored, and also we have introduced a global log level concept, which is where only a default log level is saved. We will talk about it, why, what is it is used for. Now these log levels are actually configured by VOLTHA through set list and clear commands. We'll look at that in the next slide, what are the commands available and their syntax. And these are consumed by the running pod. So the Kubernetes pods, they will read on the log level config at the startup, and then also register in the etcd against following paths: the global log level paths and its own component log level path. So let's look at one component, one, which can be, let's say, OpenVolt adapter or RW core, and that would register it. It will read the global default log level and the component log level for itself, and also register for any changes through a watch. Same way, the component 2 would do it against its own log configuration and the global log level. Now, in a running pod, one other aspect I just want to touch upon is the precedence which we have used. So the log level order of precedence is because you can configure the log level at package level, component default, and the global default. So the precedence is, I think, is going to be if there is any log level configured at the component plus package level for a package, that package would use that log level. Otherwise, it would use the component default log level. Otherwise, it will use the global default log level. So let's talk about Kafka package, which is shown as example. If there is any specific log level configured for that, it will use that. Otherwise, it will use the component 1 default log level. Otherwise, if that is also not configured, it will use a global default log level. Okay, I'll move to the next slide. So log level configuration VoltCTL, there are 3 commands we saw, right? So first we'll look at how to get the list of log levels. Uh, if you don't give any argument, it will list the logs for all the packages of all the components. But if you provide a component name, it will give it for that particular component. There's not much change there. The set log level is also the way it used to be earlier. You can set log levels as one of the 5 string values. So here you can set, if you don't give any component name, it is actually defaulting to global default level. It will insert a entry into etcd. Then you can also set the log level for a specific component. And then you can also set component log level for multiple components and package combination in the same command. One thing you would have noticed is in the second entry when it is stored in etcd, because etcd the slash character is has special meaning, so we actually change slash character in the package name to hash. Okay, that is for setting. And then the same way you can do a clear. In the clear, that particular key in the etcd is removed. So you can clear the default log level for adapter OpenVolt in this way, and then you can clear a specific for a specific package as well in this way. One thing which we have prohibited is removing the global default log level. It is not allowed to the VoltCTL command. If we do it, I think it will throw error. It has been done so that there is at least one default log level which is available, because in the order of precedence it is a bare minimum denominator, and that we don't allow to be removed. Okay, that talks about VoltCTL commands, and now I'll just look at how the component which is running handles this the consumption of the log level configuration. So when a component comes up, right, it actually loads all the log level configuration in a go routine, and they later on then it starts watching for the any changes. So as part of the initial startup, right, it do few set of steps which I think which I want to just cover to be also introduce another aspect which we have not looked at the previous slide. So basically, when the log configuration, when the pod comes up, it passes the initial log level from the CLI, which has it passed through usually to the Helm charts, right? It applies it to the all the log packages which are configured. So all the log packages defaults into the initial log level at the startup. Thereafter, it looks at the global default log level in etcd. It is, if it is available, uh, and if it is not found in etcd, it actually stores that. So it stores one as the global default level in etcd. And if it has been found, it just skips that step. So idea is that each component will try to store one log level, global default log level into etcd at the startup. And if it is not found, then it goes to the next step where the pod will look out for a default log level for that particular component which it belongs to. So if it is not present, it will save the initial log level which it got from the CLI into etcd. And if it is found, it just skips that step. So these are the only two places at the startup of the pod where the log level, the global and that component log level would be written into etcd. After that, the pod would not write anything into etcd. It will always read from etcd, the log configuration. Okay. Thereafter, it will go further and then it will retrieve all the log configuration from etcd at the global and component path level. It will construct the effective log level configuration as a map of key and value where key is package and value is the log level. So it will use the same precedence order, right? Component package as the highest, and then if not defined, use the component default, otherwise default use the global default. Then whatever effective log level configuration has been constructed, it will check if it is same as the active one by retrieving the active configuration from the logging module for each package. If it is not, it will apply the modified log levels to the impacted log packages. But if it is same, it will just skip that step and just log probably a debug message that it is same. And after that, it will start watching for any changes on global and component log paths to get notified of any config change. So this is the initial procedure which is done to basically load the configuration and apply it. We're also using hashing mechanism in between and some other optimization in between to make it better, to have a better CPU optimization. And then whenever a config changes in etcd, we get a callback. And when that callback happens, we actually do a subset of these steps, which are shown in this. So we load the whole configuration, construct the effective, and then check it against the active, and then apply it if something has changed. Okay, and that actually completes what I want to talk about this particular feature, how we are going about implementing it. And thanks to Scott and David, we got a lot of input from them to put it in this shape. Okay, then I will probably pass it over to Divya for demo, unless there are any questions which I can take up.
Thank you, Girish. Can you? Okay, let me share my screen.
Yeah, Julie,
Yes.
Divya should be able to share, right, the screen for
Should
demo?
be able to, yeah. I don't think you have to stop sharing your screen, but you may need to if she's not
Okay,
able to
yeah,
do that
sure.
right away.
Okay, yeah, sure. I've done that. Divya, you can give it a try now.
Okay. We have to select a multiple screens for this. Let me try. Okay. I,
we can see, yeah. You can see all the four I think terminals, yeah.
okay. So thank you, Girish. Myself, Divya. I'm going to present the demo related to dynamic logging for all the component suite. So first we'll start with the list commands. This setup is a fresh kind of the setup with some local images. We have modified some changes to the code, and that code changes are not at merged to the master. So we are using local images with the fresh kind of the setup. So we'll start with the list command. So if you want to see the log level set for the components at the startup, so we can use the OCTL log level list command, which will show the log level set for the components, for all the components basically, with all the packages. So we can see that the log level for the components has set for the global, then global default as a one, and for OpenFlow agent as a debug, read write core as default as a one, and for adapter openability as one. These log levels are set when the pod has started up. So in other screens, you can see that for the OF agent, there are some logs are coming in because the log level for this particular component set as a debug. So we can see some debug logs here. And for RW core, there are some error logs are coming initially. And after that, there was no error logs, so nothing is coming. For the adapter, there are no warning logs at the startup, so there are no logs for adapter component. So we can see, we can list, if you want to list out any particular component, then we can use the command OCTL log level list adapter OpenVLT. Then it will show the log level set for that specific component. Similarly, we can list the log level set for a multiple components using the command OCTL log level list, then the component 1 and component 2. In my case, component 1 is adapter OpenVLT and component 2 is a read write core. So it will list out the log level set for that for those components. Then we'll move to next command, that is set. Then I can set a global log level using OCTL log level set, then the level which I want to set it, and component name is not required to give. It will set it for the global log level, and then we can go and list it out. So it will show that the global default log level has been changed to info. And if we see the log levels in the OF agent, it is showing that there is no change in the logging configuration because the component log level has a precedence over the global default. So it has not changed here. The OF agent default log level is debug. So it has not applied on this. Then if you want to set the log level for any particular component, then specific component, we can use the command OCTL log level set, then level, and then the component name, read write core. And we can go and check using the list command that whether it has changed or not. We can see the for the read write core default log level has been changed to info. So in the RW core, I am tailing the logs here. Right now it is not showing any logs. It will start showing the logs. So we can see the logs in the RW core when we change the log level. So similarly, we can set a log level for a specific package. using a command oldctl log level set, then that log level, and then the component name and hash, then the package name. We are using hash as a package separator for the component. So if we set, then we can see the logs are coming in the for RW core. Actually, the logs will come when lineliness check happens. So it happens in some seconds. So we can see the debug logs for the DB packages are coming in. So similarly, we can set a log level for multiple components. Using the command oldctl log level set, then level, then the component 1 and component 2. Then we can list it out, it has changed or not. So you can see that log level has been changed for these two component, adapt OpenLT and rewrite core. So we can see the log level logging started coming for adapter as well. Then we can use a clear command to clear the log levels using the command oldctl log level clear adapter OpenOLT. It will clear the log level set for that specific component. Then we can go and check whether it has changed or not. Then we can't see adapter OpenOLT in the list, so it has been cleared. So after some time, it stopped coming the logs for this specific component.
Actually, it has taken the global default now.
Yeah, it is taken the global default. Sorry.
The next one logs which will come, actually that would happen only next time the liveness checks would happen. And then you will see the actual log of debug level also coming in here.
It is fallback to global level. Similarly, we can clear the log level set for package. For the read-write core, and we can it stopped coming the debug logs for DB packages. So we can go and check in the list that it has removed the package log level set for the DB package. Then similarly, we cannot clear the global default log level set. If we try to clear the global default log level, then it is throwing an error saying that global default log level cannot be cleared. Similarly, we are validating the level which has to be set, that if you are providing any invalid level, then it will throw an error saying that it is an invalid log level. Similarly, we are not validating any component name. So if we set any invalid component name, it will go and set it. So it is advised to the user that please don't set any invalid component name, because it stores in the etcd tail end. So similarly, we are not validating the package name from oldctl side. It will go and set it. If we list it, we can see that for the adapter OpenOLT, this package has been set in the etcd. But in the component level, we are basically checking for that invalid log level. So you see the logs. it will basically show that ignoring this invalid package. Then, okay, so we'll set, we'll see that how the OF agent go when pod restarts. It will load the log level which is there in the etcd. So we'll set the OF agent log level as a 1. You can see that in the OF agent logs, it is showing that it has been changed to 1 log level. Now we'll restart the OF agent. So it has taken the log levels which is set in the etcd, and after that debug logs stopped coming for OF agent.
So idea is, I think, just want to demonstrate that when it started off, right, if it finds its log level set for itself in etcd, it will start using it, which in its case is 1. But if it doesn't find it, it will store its own initial log level into etcd, which was used to be debug log level. But in this case, it found it in etcd already, so it started using it.
Yeah, I think an important point to make is that if you want to bring the system up in a particular logging state, you can configure all of this stuff in etcd before these components are even up, so that they do, initialize with that log level. So you could, we could modify the kind VOLTHA pipeline to be first bring up etcd, then configure all your log levels, then bring up your components, then every component would come up in the desired log level. That's an option to us.
Yeah, right.
Okay. Thanks, Girish and David. We can configure the etcd configuration in the file. We can do the KV-store configuration here for KV-store host and port name. And the timeout also we can give here for the KV-store. So if we give a invalid port number, then we'll try, if we try to connect to the etcd, then it will throw the error. So basically it is unable to connect to the etcd. So that's all from my side. If anybody has any questions or queries.
Yeah, this all looked very cool. I'm happy to see it all working together, and I thank you guys for doing the demo and how this feature has worked out. One thing noticing as we were doing it that I think might be helpful would be, and I think we've talked about this before, though I don't remember what our decision was on it. Maybe a warning if you try to configure a component that doesn't exist in VoltCTL. I think we decided against making it an error because we did want that capability to configure components before they're actually brought up, but perhaps issue a warning that you are configuring a component that does not exist yet. I don't know what others would think about that. It seems like it could be an easy way to prevent an administrator or operator mistyping a component name and then ending up with a state in etcd that he thinks is for a component, but there's not actually a component by that name.
Yeah, we can probably look at that at the next step. But I think we initially thought of that, but we wanted to probably reduce the dependency on the Kubernetes API to look up those component names. But if you're, I think if the community is okay to do that, I think we can introduce undead checks as well.
If you look it up in etcd, because each component when it comes up is supposed to store its own default level, so you could list all the default levels. find out if it's there that way.
Yeah, but I think it's not a foolproof procedure because the default log levels, right, can be removed, right? So
Right.
if you remove,
Right.
That would only tell if the component's actually up and running. It would
Yeah.
not work before a component was up and running, like Scott was talking, in pre-configuration.
Right. Well,
Which is true about Kubernetes too, using their API.
That's why it should only be a warning, right? Not an error. It should still go through and configure it. It should just warn you. The other thing related is if we were able to grab that, it would be very nice to have autocomplete on the listed components.
Yeah, sure. I think, yeah.
I'd almost, well, again, part of the reason it was done this way without verification was the idea that VOLTHA is a set of components that is not completely known. I.e., well, we have some core VOLTHA components. Someone else could come up with their own adapter and add it in to the mix. And we didn't want to prevent that nor have that cause even a warning in particular. That's why it's kind of written that way. We could, if we relied on either what's in etcd already, based assuming the component started, yeah, then we could use that and do completion, which would be nice. I don't know. I'm a little hesitant about the warning, just because, well, again, we don't know the full set of components, and do we really want a warning if the you're trying to set a log on a component that is not yet started?
I think as long as we phrase the warning properly and we say, warning, you're setting logging on a component that has not yet started, then, we're not telling the user the component doesn't exist. We're telling him it's not started yet. The user may say, fine, I know it's not started yet, and continue along. I guess that's my thought. It's so easy to accidentally mistype a name. You call something open-OLT instead of open, no character OLT, and then it's in etcd and it looks right. And I think that's where confusion could come from. Another thing we could do in the log level list, if there was a way to convey components that are up in that same list, that when you did a log level list, you would see, okay, I've configured OpenOLT to be warn level, and that component has started. Then an operator looking at it would have a red flag. I configured this, and it's in the database, but the component never started. Why did it not start? Well, maybe it didn't start because I've named it the wrong thing.
I think that would be nice to have, but I don't see how we'd get that from the data easily. Unless we add a key in the database that each component is supposed to keep updated based on whether it's up or not, and that obviously won't work if it crashes.
Well, if it was a key that said whether you've started, then it doesn't need to be that you're up.
Right.
So it's kind of like the state we're writing now, that as soon as you start, you write your default log level to etcd.
Basically, it was started at one point sometime before it, and after etcd was started. It's in the etcd database is all we're really saying.
Yeah, that's all it would be. And it would just be a confirmation the component, sort of does exist. May not be running. If you want to know whether it's running and whether it's healthy, you need to go elsewhere to find that state.
But I think that information is retrieved through that other path, right? VoltCTL component list, right?
Yeah.
Yeah.
In the same token, is there a way to retrieve the package name per component?
The packages within the component?
Yeah.
Not unless we wrote all the packages out at startup or something.
Because at the VoltCTL level, when we are trying to set up the log level for package, for components already, we may saying, oh, maybe we're putting something wrong, but surely for package name, which is much longer, first, may not be known, and second, there's a higher chance of making a mistake there. If we can list all the packages per component, then it's a little bit easier to set it up.
Yeah, I agree. That would be really handy to do that. I think some of this we kind of thought maybe let's try to figure that out for phase 2, and you know, for phase 1 we would assume the developer knows the component names, since this is a developer aimed. Debugging specific packages is kind of a developer aimed thing, that the developer knows what package he wants to debug, knows the name of it. And for phase 1, we could make it a little bit more onerous, that you'd have to know that. But for phase 2, we could look at some way to populate the etcd store with package names.
Yeah, that's all right. This is just I think something that will be handy, as long as it's on the something that we'll do eventually, then that's good.
Yeah, or the alternative is we have very good documentation that lists all the package names.
Well, and it will keep changing, right? If I add a new package, it will just there will be a new one.
Yeah, and that's not been one of our strong suites, is keeping documentation up to date with code changes. So
it also becomes a cleanup issue if you remove a packet. You know, let's say we started the system, it wrote everything to etcd. You remove a package, unless components are periodically refreshing that setting in etcd, deleting keys as well, it gets stale real quickly, or has the potential to get stale quickly.
I think it would be nice to have. I don't think. Well, it's a lot of implementation and a lot of things to track for that in particular, for the list of packages.
Yeah, I think a quicker, cleaner way of doing it would be, I think, because all the log packages do call up that log module to register, right? So the quick way of doing it is probably push it in that information into etcd at startup, and then probably pull it from there to VoltCTL for list of allowed packages for each component. So that can be done, but yeah, I mean, that would need some additional changes into.
Yeah, I think the larger question there is, if we do that, like that part's not too difficult. The question is, how do we do cleanup, and how do we do sort of something disappear?
I mean, the simple case is every time a component starts, it cleans up that. It does it once at startup.
So then, if you pre-configure something and then you happen to not have that package, it just silently deletes it. Or anyways, all this to say, there's a lot of subtle complexity in it.
I think we should.
But there's two issues there. There's the it could be that the packages or the components write the list of packages to etcd. That is separate from the settings. So it's possible where they write, you know, the list of packages, you know, A, B, C, D, and then when you come and set package A, package Z, even if Z doesn't exist, maybe we write it, but when that component starts up, or it gives a warning in the log that, hey, Z was set, Z doesn't exist, right? So I would keep the list of things or the potential options separate from the actual settings. Does that make sense?
Makes sense.
Yeah. I was also thinking of that, so that it's just one key which is written with probably separate, comma separated list also. But it is different than the actual log level which are active.
Yeah, I agree with this proposal, keeping these two things separate. And you know, furthermore, one of the decisions we kind of made with this, I think early on, was that we would not really automatically prune operator settings. You know, if the operator sets something, it stays in etcd until the operator removes it. So cleaning up the list of available package names, I think, is fine, but actually going in and cleaning up a setting that the operator intentionally set, I think that would be something to consider
Yeah, I think what that would be leaning to if we did all this, you'd also want to add commands like check, which kind of reports which are valid, which are not, or prune, which gets rid of invalid ones, right?
Or you even just in the list command have it have one of the fields be sort of a warning if it doesn't exist.
Yeah, yeah.
Yeah, seems good.
Yeah, but I think we should kind of jot these ideas down in a JIRA and propose this as work for the next release after feature freeze is complete. Yep. Because I think from a usability perspective, I think this would be really handy to have available component names and available package names. And if we can do one, we can do the other. And then think about after we've got that, any automatic or not automatic, but sort of assisted pruning or assisted checking and stuff like that. It all seems doable.
I mean, again, like Scott said earlier, it's great to have this. This is good stuff, right? I was playing with it a little bit last night, and now we just need experience with it and figure out what works best as we actually start troubleshooting and working with it kind of more in an operational state. VOLTHA in an operational state, being able to change logs. So again, thank you for this. It's good stuff.
Do you have any other questions or comments?
Hi, this is Amit. I have a question. So are there any thoughts on how to get the Python ONU adapter hooked onto this?
Actually, we are working on it. So there's a JIRA which is being worked upon, but we are actually facing some issue with the watch mechanism there. We were not getting the callback, but we had to modify some things in the twisted framework to do that. So making some progress. I'm not too sure whether we will be able to complete that part in this for the VOLTHA 2.3, but we're giving it a try if we can get the patch set in by end of this week.
Yeah,
But there, I think the problem we faced is we don't have, like in VOLTHA, we have one package, right? One package is defined as the common one shared by all the files in a directory. But there, that's not the case. We are going with the module, so each file is a module there.
Yeah. Okay.
Yeah.
Thanks.
Thanks. Yeah.
Thank you all.
Yeah, thanks, Uli. I think, yeah, we're done.
All right. Thank you very much. Let me go ahead and start sharing my screen again. And go back to the agenda. All right. So next we have just a couple brief topics or comments. And the first one is that we are nearing code freeze. We're about a week out, I believe. So wanted to bring up a comment on patch management that I know has been brought up on at least one of the other brigades. And so that is to add a prefix. Here we have it listed future with vol and then the reference number for it to all patch sets that are not intended to be merged in for this release. And so David or anyone else, if you want to make any comments, feel free.
I think that pretty much says it.
All right. So if we could have everyone work on doing that, if you have a patch that you are not planning to have merged in, please get that done quickly so that it will aid as we're doing the planning for the upcoming release. And then the next, just a brief comment as well. And David, I'll let you take this one. This is about kind VOLTHA moving to OF Agent Go as the default. David, anything else you wanted to add there?
Yeah, just to reiterate, so that means any test in our test suite or in your own testing in your environment that doesn't explicitly say use the Pi version would default to the Go version. And part of this is I just want to make sure there isn't anybody foresees any problem with this moving over before I actually commit this change. And so I just wanted to make sure it was visible. Anyone? And just as I guess another comment, is Rob on the call? I don't see him. Is it the? I wanted to verify it is the case that the new release, the release coming up 2.3, will be defaulting to the OF Agent Go Is that accurate? That is
that's my understanding, David.
Okay.
Yeah.
And work, I was handling work on OF Agent Pi, and that work has stopped because of the switch to OF Agent Go.
Okay. So I will work to make that change today if there's no objections. All right, thank you.
All right, thanks, David. Then I did not see a lot of new non-brigade related JIRAs. So I think 2766 was one that may not be associated with a brigade. I'm not sure. A defect that was raised related to the DT workflow. Pings fail with the default technology profile, which is 1 TCONT, 1 GEM. And I've got part of my screen blocked by the participants, so let me move that so I can see. Okay, it looks like to open this one.
Yeah, this one should be, no, Radisys is working on it. I'm not sure why it's on my name.
This is actually a duplicate bug that has been created by someone. The BAL Brigade already has a similar bug.
Okay. So we will look for that, see if we can get it linked.
I'll do that. I know which is that Jira, so I will duplicate this one to the original issue.
Okay, thank you very much. And then earlier I did not see any requests for all discuss items. So let me do another quick refresh on the screen and nothing found. So I think that wraps up our agenda for today. Let me open it up, see if there are any additional questions or comments that people would like to make for the group in the remaining few minutes. Okay, I'm not hearing any, so I think we are done with today's call. I will go ahead and stop the recording, and we will conclude today's call. Thanks, everyone.
Thank you.
Thanks. Bye.
Thanks.